Welcome back, everybody. Hopefully everybody is staying healthy. I wish you all the best. This is section 5.5, multiplying polynomials together. In order to multiply polynomials together, we need to remember that in general, when we multiply like bases together, we keep the base the same and we add exponents. All right, let's dive right in and start multiplying some polynomials. So the instructions will say multiply or simplify. I'm going to take this monomial 5x and we're going to multiply it by this trinomial 4x cubed minus 5x squared plus x. In order to multiply this monomial by this trinomial here, we're going to have to multiply the monomial by each term of the trinomial. So 5x first of all gets multiplied by 4x cubed. And I love to use these arrows as a visual cue. I strongly recommend that you also use them. So we got 5x multiplied by 4x cubed plus, I will always put a plus sign in between my products. Then we're going to take 5x and multiply it by a negative 5x squared plus, and then I will take 5x and multiply it by x. Now it comes down to, can we multiply like bases together? So 5 times 4 rather would give us 20, and x to the first power multiplied by x cubed gives us x to the 1 plus 3 power, or x to the fourth power. We have a positive times a negative. A positive 5 multiplied by a negative 5 will give us a negative 25. And therefore, instead of saying plus a negative 25, I'm just going to say minus 25. And when you multiply like bases of x, I have x to the first power multiplied by x to the second power. That will give me x to the 1 plus 2 power, or x to the third power. Finally, at the end, I have a positive 5x being multiplied by x, so plus 5 times technically 1 as the coefficient in front of x here. So 5 times 1 is 5, and x multiplied by x is going to be x to the 1 plus 1 power, or x squared. Notice we don't have any like terms that need to be combined in this expression, so that would be our final product of this monomial and this trinomial. All right, we'll try another one. 3a squared b multiplied by a cubed plus a squared b squared plus b cubed. Again, we have to make sure this monomial gets multiplied by each of these terms inside the parentheses. To ensure that, I like to use arrows as a visual cue. So we're going to take the 3a squared b, we're going to multiply it by a cubed, plus 3a squared b is going to have to get multiplied by a squared b squared, plus 3a squared b will have to get multiplied by b cubed. So 3a squared b multiplied by a will give us 3, and a squared times a cubed is a to the 2 plus 3 power, or a to the 5th power. And this b has nothing to multiply by, so b just comes along as a factor. Plus 3a squared b multiplied by a squared b squared, really 1a squared b squared. 3 times 1 is 3. A squared multiplied by a squared is going to be a to the 2 plus 2 power, or a to the 4th power. B to the first power multiplied by b squared is b to the 1 plus 2 power, or b cubed, plus 3a squared b multiplied by b cubed, or 1b cubed. 3 gets multiplied by the 1, which gives us a 3. A squared has no other base of a to multiply by, so we just bring the a squared down as a factor. And finally, b, or b to the first power times b to the third power, is b to the 1 plus 3 power, or b to the 4th power. Notice there's no like terms to combine, so that would be our final product of this monomial and this trinomial. All right, take 6xy cubed and multiply it by 2x squared minus 5xy minus 12y squared. The 6xy cubed is going to have to get multiplied by all three terms inside the parentheses. So 6xy cubed will get multiplied by 2x squared plus 6xy cubed will get multiplied by a negative 5xy plus 6xy cubed is going to get multiplied by a negative 12y squared. 6 times 2 is 12. X, or x to the first power, multiplied by x squared is x to the 1 plus 2 power, or x cubed. And we have y cubed that has nothing to be multiplied by, so y cubed just comes along as a factor. Here we have positive 6 being multiplied by a negative 5. 6 times a negative 5 is a negative 30. Instead of saying plus a negative 30, I'm just going to say minus 30. X, or x to the first power, multiplied by x to the first power is x to the second power. Y to the third power multiplied by y at the end here is y to the 3 plus 1 power, or y to the fourth power. And then 6 multiplied by a negative 12 will be a minus 72. X, or x to the first power, multiplied by, well, there is no other base of x to multiply this x by, so we just bring the x along. And finally, y cubed times y squared, y to the third power multiplied by y squared is y to the 3 plus 2 power, or y to the fifth power. And that would be our final answer for that problem there. So I've shown you several examples of how to multiply a monomial by a polynomial. Now we'll look at how to multiply two binomials together. Now there's many ways to show how to multiply binomials together, but I'm just going to pretty much stick with one method, which is the typical method you see in most textbooks. To multiply these two binomials together, we're going to utilize an acronym called the FOIL method. F-O-I-L. F stands for the first terms being multiplied together. O stands for the outer terms being multiplied together. I stands for the inner terms being multiplied together. And L stands for the last terms being multiplied together. Most textbooks teach this technique. And again, arrows are going to be a very important visual cue to make sure that we cover all the bases. So I'm going to take the x, the first term of the first binomial, and multiply it by both terms of the second binomial. So x is going to get multiplied by x. X times x. Plus, and again, I will always put plus signs in between my products. Now x, the first term of the first binomial, will get multiplied by the second term of the second binomial. X gets multiplied by the 5. X times 5. Plus, then the 2 will get multiplied by the first term of the second binomial. 2 gets multiplied by x. Plus, and then finally the 2 will get multiplied by the last term of the second binomial. 2 gets multiplied by 5. When I took the x and multiplied by the x, I was multiplying the first terms of my binomials together. For that reason, this product represents the product of the first terms. F for the word first. When I multiply the x by the 5 way over here, that represents the product of the outer terms of the binomials, the terms that are furthest away from each other. So x times 5 represents the product of the outer terms, hence the letter O for the word outer. Then I abandoned the x and moved over to the 2. When I multiply the 2 by the x, I multiply the inner terms of the binomials together, the terms that are closest to each other. So 2x represents the product of the inner terms, I for the word inner. Finally, I multiplied the 2 by the 5 which represents the last terms of the binomials being multiplied together. Hence 2 times 5 represents the product of the last terms, L for the word last. And what you get is the word FOIL here. So the FOIL algorithm is a very popular way of multiplying binomials together. Now it's just a matter of cleaning up these products and adding together the two middle-like terms. So x to the first power times x to the first power is x to the 1 plus 1 power, or x squared, plus x times 5 is more conveniently cited as 5x, plus 2x, plus, and 2 times 5 at the end is 10. Now to wrap up this product, we have to add together the two middle-like terms. In other words, we need to combine these two middle-like terms, and therefore we would get a final product of x squared plus 5x plus 2x is 7x plus our 10. And that, ladies and gentlemen, would be the product of these two binomials utilizing this FOIL algorithm, or FOIL way of multiplying these binomials out. All right, maybe we can try another one here. I will now multiply 3x plus 6 times 2x minus 1. Again, we'll use the FOIL algorithm. So let's multiply the first terms together. 3x gets multiplied by 2x, plus, then we multiply the outer terms of the binomials together. That means to multiply 3x by the negative 1 out here, plus, then we abandon the 3x and move to the 6, and now the 6 will get multiplied by the 2x. That'll be the product of our inner terms of our binomial, 6 times 2x, plus, and then we multiply the last terms of the binomials together, 6 being multiplied by negative 1. Okay, let's clean this up. Now 3x multiplied by 2x, 3 times 2 is 6, x times x is x squared. 3x multiplied by a negative 1 will be a negative 3x. Instead of saying plus a negative 3x, which I could, I'm just going to say minus 3x. Plus 6 multiplied by 2x is going to be 12x. And finally, 6 multiplied by a negative 1 at the end will be a minus 6. I could say plus a negative 6, but I'm just going to say minus 6. To wrap this up, we need to combine the two middle-like terms. Don't forget to do that. Hence, we'll have 6x squared. Now, minus 3x added to a 12x is going to be a plus 9x. And then we got the minus 6. And that would be the product of these two binomials, again, using the FOIL way of doing things. This next example is going to be an interesting example. We're going to take x plus 3 and multiply it by x minus 3. Again, we're trying to multiply two binomials together, so we'll use the FOIL algorithm way of doing things. So we take the x of the first binomial and multiply it by the first term of the second binomial, x. So x times x is the product of the first terms of the binomial. Plus, now we'll multiply the outer terms of the binomials together. That's to say we multiply x times a negative 3. Plus, now we multiply the inner terms of the binomials together. That is to say we multiply 3 times 1x, or 3 times x. Plus, and then we multiply the last terms of the binomials together. That's to say we multiply a positive 3 times a negative 3. Okay, x times x is x squared. Here we have plus a negative 3x plus 3x plus a negative 9. 3 times negative 3 is negative 9. Instead of saying plus a negative 3x, I'm just going to say minus 3x plus 3x. Plus a negative 9 is the same thing as saying minus 9. Notice when we combine the two middle-like terms of this binomial, they cancel out. They add up to 0x, or they're gone. And our final product of these two binomials is going to be x squared minus 9. Ladies and gentlemen, when two binomials differ only by the signs in between their terms, they are called conjugates of each other. So these binomials are conjugates of each other. Conjugates. And in general, whenever you multiply conjugate binomials together, the two middle terms will always cancel out and disappear. That's always the case. Okay, let's now turn our attention to multiplying. How about a binomial by a trinomial? How about a plus 5 times a squared plus 2a plus 3? I want to point one more thing out. When we multiplied binomials together, notice we multiplied a two-term polynomial by a two-term polynomial. And 2 times 2 is 4. That means we'll have 4 products when you multiply two binomials together. Notice you count 4 arrows also, one for each product. 1, 2, 3, 4 arrows. You have 1 product, 2 products, 3 products, 4 products. When I multiply a two-term polynomial by a three-term polynomial, I'm going to get 2 times 3 or 6 products. So when I get done, I better see 6 arrows and I better see 6 products. Now there is no nifty little algorithm name to multiply a binomial by a trinomial. We just got to make sure that each term of the binomial gets multiplied by each term of the trinomial. And arrows will help us keep track of things. So please do use the arrows. Let's take the first term of the binomial and multiply it by all 3 terms of the trinomial. So first a will get multiplied by a squared plus a now gets multiplied by a 2a plus a will now get multiplied by the 3 plus now I'm going to abandon a since I've multiplied a by all 3 terms of the trinomial. We move to the 5, and now the 5 will have to get multiplied by all 3 terms of this trinomial. So 5 gets multiplied by a squared plus 5 gets multiplied by 2a plus 5 gets multiplied by the 3. Now we take care of all these products. A to the first power times a squared is a to the 1 plus 2 power, or a cubed. A times 2a is going to be 2a squared plus 3 times a is plus 3a plus 5a squared. 5 times a 2a is 5 times 2 or 10, so this will be 10a. 5 times 2a is 10a. And 5 times 3 is 15. Now, please don't leave your answer like this. This is screaming for us to combine like terms, so make sure you always combine like terms to wrap your problem up. A cubed has no like term to combine with, so a cubed will be our highest degree leading term of this product. 2a squared gets multiplied by 5a squared. I'm sorry, not multiplied. We combine 2a squared and 5a squared. So 2a squared added to 5a squared is going to give us 7a squared. I apologize for that. Then we have a plus 3a that must get added to a 10a. So 3a added to a 10a is 13a. And finally, our constant term at the end has nothing to combine with, so we just bring it down as part of our answer. And ladies and gentlemen, that would be the product of our binomial and our trinomial. And notice our product is written in descending order: 3rd degree term, 2nd degree term, 1st degree term, and 0th degree term. Now we're going to multiply a binomial by a trinomial. To do so, again, we have to make sure that each term of our first polynomial gets multiplied by all the terms of the second one. So we'll start off by taking 3x and multiplying it by x squared. Plus 3x gets multiplied by negative 7x. Plus 3x gets multiplied by the 8. Plus, we've exhausted all the products with 3x, so let's now move over to negative 2. We'll view this as a negative 2. Then we'll take the negative 2 and multiply it by the x squared. So we have plus a negative 2 times x squared. Plus, negative 2 will get multiplied by negative 7x. Plus, and then the negative 2 will get multiplied by the 8. Okay, 3x multiplied by x squared is going to be 3x cubed. 3x multiplied by negative 7x. 3 times a negative 7 is minus 21. And x multiplied by x is x to the second power, or x squared. 3x multiplied by 8 is plus 24x. And we have a negative 2 multiplied by x squared, which is minus 2x squared. And negative 2 multiplied by a negative 7x is going to be a positive 14x. And negative 2 multiplied by 8 is a minus 16. Now we combine any like terms that we have. 3x cubed has no like term to be combined with. We do have a negative 21x squared that must get combined with a minus 2x squared. So what's negative 21 subtract 2? That gives us negative 23, so minus 23x squared. Excuse me. So we combined our second degree terms. Now we combine our first degree terms. We have a 24x that must get added to 14x. And 24 plus 14 is 38, so plus 38x. And finally, the minus 16 at the end has nothing to combine with, so we just bring it on down. And ladies and gentlemen, that would be our product of this binomial and this trinomial. And notice our product is written in descending order as the degree of each term decreases from left to right. Third degree term, second degree term, first degree term, and 0th degree term. Just want to point one more thing out in closing. Notice we had a 2-termer times a 3-termer, and 2 times 3 is 6, so we do count 6 arrows, as we should. And we also have 6 products. 1, 2, 3, 4, 5, 6 products. I hope you enjoyed this lecture. Hopefully you are staying up with the homework. Try not to get behind, ladies and gentlemen. The key is to, look at these videos, do the activities that I also post on Blackboard, and I will write the solutions out to those activities. Make sure you try to do the problems first and then check your answers, or if you get stumped, look at the solutions. I wish you the best of luck. Hang in there. Talk to you later. Bye.